What does one of America's fastest production vehicles have in common with America's premium motor car? Let's take a look. They're both powered by the powerful LT1 V8 engine. The LT1 in both cars uses a new ignition system, the angle-based ignition timing system, or ABITS. Hi, I'm Chuck McLennan. In this program, we'll look at ABITS operation and diagnosis. But what are the advantages of ABITS over a more traditional high-energy ignition system? Today, we have Mr. Charlie Gipe, an automotive service engineer from Delco Remy, to answer this and other questions. Charlie, welcome to Buick Know-How.
Thank you, Chuck. ABITS has more resolution than older high-energy ignition units. HEI units use a magnetic pickup assembly to send a reference signal from the ignition module to the ECM. The 8 teeth of the timer core line up with the 4 teeth of the pole piece assembly. Voltage is induced in the pickup coil, and this signal is sent to the ignition module. Older HEI systems were time-based, one time signal for each firing event. The ECM had to calculate the correct time to fire the spark plug from this one signal. In contrast, ABITS uses a signal disk that provides the PCM with the exact crankshaft position, even during periods of acceleration or deceleration. From a durability standpoint, ABITS is a 100,000-mile system, meaning that under normal operating conditions, it shouldn't require service for 100,000 miles. There aren't any scheduled service intervals for the unit. Chuck, let's look at the components that make up ABITS. Why don't you do this one?
Thanks. You give me all the hard stuff. In order to see the ABITS, I had to remove a lot of components. You can see it's located behind the water pump. The distributor shaft is driven by the camshaft. A pin in the camshaft sprocket engages a slot in the distributor. This is known as pin drive. ABITS units on other GM vehicles use spline drives. The pin drive system is a more robust design than earlier and present spline drive ABITS distributors. The pin drive units can be identified by the forced air ventilation system, which we'll talk more about in a few minutes. Inside the ABITS, there is a rotor with a wide spark edge segment, making for long life and reduced radio frequency interference. Underneath the rotor and protection shield lies the heart of the ABITS. Bolted to the pickup assembly is the optical sensor. The optical sensor consists of 2 LED photodiode pairs. The optical sensor is mounted so that a 2-track signal disc rides between the LED and the photodiode. The signal disc is connected to the distributor shaft and turns with the camshaft. The PCM sends 2 5-volt reference signals to the optical sensor. As the signal disc turns, the 2 rows of slots on the signal disc pass between the LED photodiode pair. This results in 2 pulsing signals. These signals are used to toggle the 2 5-volt reference signals that are sent from the PCM to ground or 0 volts. The outer ring of the signal disc contains 360 slots, which provide 720 timing edges for the PCM. This is known as the high-resolution signal. The inner ring of the disc has 8 slots, each of which have a leading edge 45 cam degrees away from the next slot. These leading edges also mark the location of top dead center for each cylinder. The slots are of different sizes, enabling the PCM to identify specific cylinders. The PCM does this by counting the high-resolution signal as the low-resolution slots pass the optical sensor. Different length low-resolution slots enable the PCM to identify the different cylinders. Using the information generated by the optical sensor and slotted disc, the signals from the optical sensor to the PCM can precisely determine individual piston position. Once this has been determined, the PCM uses the high-resolution and low-resolution outputs to time spark delivery. Using inputs from the low-resolution signal and additional parameters, including the engine coolant temperature sensor, the manifold absolute pressure sensor, the knock sensor, and battery voltage, the PCM calculates coil dwell and spark advance. From a low-resolution signal going high, the PCM starts counting high-resolution signals to deliver the beginning of coil dwell and spark advance. The PCM then generates an electronic spark timing or ignition control output for the ignition coil driver module. The ignition coil driver module turns on the primary current to the ignition coil when the ignition control voltage goes to approximately 4 volts. When the PCM counts enough high-resolution edges to reach the calculated spark advance, it terminates the ignition control signal, and the ignition coil driver module turns off primary voltage to the coil. When the ignition control signal stops, the primary current in the coil switches off, inducing high voltage in the coil secondary winding. The high voltage runs from the secondary side of the coil to the rotor and is distributed to the correct spark plug. With ABITS, the ignition coil driver module's role is much simpler than with other electronic ignitions. The ignition coil driver module acts as a switch for the PCM and doesn't provide a backup mode. This is often referred to as a minimum function mode or min function. Like the HE distributor modules that preceded it, the ignition coil driver module does have a built-in current limiting feature. The ignition coil driver module allows coil primary current to build up to 6 amperes. While the ignition coil driver module is smaller than an HE distributor module, it's still important when installing a new module to coat both the heat sink and module base with thermal conductive grease. This grease helps the module dissipate heat. While the aluminum cast surface of the heatsink looks smooth, there's a lot of airspace, and air is a great insulator. Conductive grease fills the air holes and allows the heat to flow from the module to the heatsink. Without the grease, the module can overheat, and that can certainly lead to module failure. Continuing with the ignition system components, the ABITS distributor cap differs from the traditional HE cap. ABITS introduces encoded secondary towers on the distributor cap. Conductive ink traces connect the rotor to the spark plug cables through non-radial paths. By using conductive ink, the towers can be positioned on the cap to allow the most effective secondary spark cable routing. The ink traces are then encapsulated with epoxy to isolate the high voltage being distributed. Using ink traces, the ABITS distributor has 4 spark plug wire attachments on each side of the cap. As a result, the spark plug wires can be routed neatly from the distributor without causing crossfire problems. Proper ventilation system operation is critical to ABITS performance. The ventilation system prevents moisture buildup and clears the ABITS of corrosive gases formed by the high voltage arc. When ABITS was first introduced on the 92 Corvette, it had a passive ventilation system, which consisted of ventilation holes drilled in the top of the case. One of the byproducts of the transfer of high voltage is ozone. Ozone is heavier than air, so it settles on the bottom of the distributor. When the ozone combines with nitrogen and moisture in the air, it forms nitric acid. This nitric acid can create conductive paths inside the distributor and cause misfires and crossfires. The nitric acid attacked the terminals in this HEI distributor cap. The corrosive problem was solved by moving the vent holes to the bottom of the ABITS. The ABITS system used on the Roadmaster was further improved with a forced ventilation system. The forced ventilation system has a fresh air inlet and a vacuum line. The fresh air inlet runs from the distributor to the air inlet duct located just after the mass airflow sensor. By plugging into the air line after the mass airflow sensor, the clean, filtered air is accounted for by the PCM and doesn't affect the fuel mixture. To draw fresh air through the distributor, a vacuum line runs from the distributor to the intake manifold. An orifice tube and filter is placed in the vacuum line. The blue side of the filter faces the intake manifold. Just up from the orifice tube there is a check valve. The check valve prevents air from returning to the distributor. Charlie, I understand that an inoperative ventilation system is one of the causes for misfire with ABITS.
That's correct, Chuck. Let me demonstrate. Located down here is the air inlet line for the distributor system. If this becomes pinched or plugged for any reason, you'll draw a vacuum on the distributor. As the vacuum is created inside the distributor, the dielectric properties inside there will also begin to go down. And as that happens, the spark that normally would travel from the center of the distributor cap through the rotor and to the terminals located here will find it much easier to travel from the center of the cap to the fastening screw on the rotor, which is a ground, which will create a misfire.
So, that's how it happens.
Other problems may result if the air inlet line is plugged. In some cases, engine vacuum is strong enough that it draws the distributor cap down until it contacts the rotor.
There's enough vacuum to actually bend the distributor cap. Amazing. Any tips on checking the ventilation system?
Yes, but first let's start the car, Chuck.
Okay.
Unplug the air inlet of the distributor and place your finger over it, checking for a slight vacuum. Don't forget to plug the hole in the snorkel.
Charlie, what about checking that with a vacuum gauge?
That's also a good test to perform, Chuck. What you would do is remove the air inlet line from the snorkel, making sure that you plug the snorkel, and then connect the vacuum gauge up to the air inlet line. As the engine runs, the vacuum gauge should drop down to very near what the intake manifold pressure is. Also, check for pinched or damaged hoses, a plugged orifice or check valve, and for a poor seal between the distributor cap and base. Remember, the ventilation harness is serviced as an assembly only. Proper ventilation is essential for good ABITS operation. While a plug vent system may cause misfires, you need to check other typical causes of misfires such as foul plugs and spark plug wires.
A misfire may be caused by a ventilation system problem, but causes of no spark or intermittent complaints require additional diagnosis. Begin your diagnosis with the ignition system check in the Know-How Technician's Manual. The first step is to check for trouble codes using the Tech 1. In addition to code 42 found on most ignition systems, ABITS has codes 16, 36, and 41 to aid in the diagnosis of ignition problems. A code 16 is set if 720 high-resolution signals are seen by the PCM without a low-resolution signal. In other words, if the camshaft turns one complete revolution and the ABITS doesn't provide a low-resolution signal for piston location, the PCM sets a code 16. The optical sensor diode for the high-resolution signal must operate before a code 16 is set. A code 16 can be caused by an open, shorted, or grounded low-resolution wire, an open terminal, a failed optical sensor diode, or a failed PCM. Remember, an engine with a code 16 won't start. A code 36 is set if the PCM does not receive a high-resolution signal for 9 consecutive low-resolution signals. A code 36 can be caused by an open, shorted, or grounded high-resolution wire, an open terminal, a failed optical sensor diode, or a failed PCM. A code doesn't set when both optical diodes fail, but then the engine won't start either. The last two codes are related to the ignition control circuit. A code 41 sets if an open exists in the ignition control circuit. The PCM looks for voltages above 4.5 volts on the ignition control line. When engine speed is below 1500 RPM, a code 41 sets if there is an open in the ignition control line, or if the ignition control line is shorted to voltage that is higher than 4.5 volts. A code 41 also sets if there is an open terminal, a failed ignition coil driver module, or a failed PCM. A code 42 is set if the ignition control line is grounded. The PCM considers the ignition control line grounded if voltage remains less than 4 volts. A code 42 is most likely caused by a grounded ignition control wire, but it could also be caused by a bad ignition coil driver module or a failed PCM. Code 41 and 42 are stored in memory and don't turn on the malfunction indicator lamp. If either a code 41 or 42 is detected, the engine won't start and the PCM disables the fuel injectors to prevent engine flooding. Remember, there is no ignition system backup in the ignition coil driver module. The extensive diagnostic codes used in ABITS should help make it easier to locate problems. However, not all problems can be found through trouble codes. This is where the ignition system check chart becomes invaluable. The ignition system check chart provides an organized approach to ignition diagnosis. After checking for trouble codes, check for spark with an ST125. This is an excellent test when searching for a misfire. The ignition system may be providing enough voltage to run the engine, but not enough to fire the spark plugs under a heavy load, resulting in a misfire. Since the ST125 requires 25,000 volts to fire, it can be used to make sure the ignition system is producing adequate voltage. If the system isn't producing adequate voltage, check the voltage in the primary ignition circuit. Disconnect the ignition coil driver module connector and, with the ignition on, check the voltage from harness terminals A and D to ground. If the coil is receiving adequate voltage, both terminals should register 10 volts or more. Next, connect the probes to terminal B, the ignition control line, and ground, and set the DVOM to the AC scale. Crank the engine. There should be between 1 and 4 volts. This check is the first step in determining if the PCM is providing a signal to the ignition coil driver module. If the PCM isn't providing a signal to the ignition coil driver module, the problem exists between the distributor and PCM. If there wasn't 1 to 4 volts, the ignition system check examines more closely where the signal from the PCM is breaking down. Using the Tech 1, see if there is a low resolution signal. If there isn't a low resolution signal, turn the ignition off and disconnect the distributor electrical connector. Turn the ignition back on and probe terminal C with a test light. The light should illuminate. If it doesn't, there isn't any power going to the optical sensor. The remaining checks test the various circuits individually to determine if the proper signals are being sent and received from both the distributor and PCM. If the light illuminated in the last test, check for continuity between distributor connector D and ground. The circuit should have continuity. Then, using a DVOM on the DC scale, measure voltage at distributor connector terminal A, checking the low resolution signal. Voltage should be about 5 volts. Repeat the measurement at distributor connector terminal B, checking the high resolution signal. Voltage should also be about 5 volts. In this way, the ignition system check chart thoroughly tests each component of the ignition system. Many ignition system failures are intermittent in their early stages. These are especially difficult to find. Charlie, do you have any suggestions on how to diagnose intermittent ABITS ignition problems?
As with other ignition systems, the best approach is to try and reproduce the conditions under which the problem occurs. Usually this means vibration or thermal stress. Raising engine coolant temperature or operating the engine at a specific RPM may bring out the failure. I'll show you how to check for misfires. Misfires may be intermittent in that they appear only when the engine is under a load. Misfires are also usually due to a spark plug or secondary wire that is leaking high voltage. If the engine misfires only under a load, mist the wires with water from a vegetable sprayer like this. Spark that is escaping from the secondary circuit usually can be seen under these conditions.
This one seems okay. Charlie, are there parts available for the ABITS distributor?
For the first year, there won't be any service parts available. The ABITS distributor will only be serviced as a complete replacement unit.
Good. Hey, thanks for stopping by.
You're welcome.
Problems with the ABITS should be rare. It's designed to last, to be efficient, and to help Buick remain the new symbol of quality in America.